All right, here we go, kids. Here we go. Moving on. Unit. Oh, day 10. We only got 2 days left. Woohoo. And the last one's really not a full day. It's probably just kind of like exercises we'll probably do at some point. All right. We're going to compare and graph and compare trigonometric functions. So there's only 4 questions, but they take a little bit of time to do them. So we probably ought to get an idea what's going on. This is a normal cosine function and a normal tangent function, and we want to find out when, I know this is hard to see, but really what it says is when does f of x equal g of x? Well, by equal, graphically, we mean when do they intersect? So let's graph these suckers. We're only going from 0 to 2 pi, so I can put my y-axis over here. And since there's really no shifts, I'll put my x-axis somewhere in the middle. It doesn't have to be perfectly in the middle. Now I'm going to graph tangent first because tangent's got some asymptotes. So we're just going to do our normal, sorry kids, we're going to do our normal ticks here. I don't know. Let's say I got to do 4 ticks. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this will be pi over 2, pi, 3 pi over 2, and 2 pi. All right. Let's see, tangent. Now, tangent's got, let's see, remind myself, tangent of x is sine of x over cosine of x. So wherever cosine equals 0, that's where I have asymptotes. 1, 2, 3. Maybe I'll graph cosine first. Maybe I will graph cosine first. All right, so there is no midline, so that makes this pretty easy. I don't have to go through all that stuff. The amplitude is 2, so cosine is going to start at a max. It's got a frequency of 1, so it's going to end at a max. And in between will be at a minimum. And in between there we'll be on our zeros. Try to graph this rather neatly. There it is. So that one I did in red. Let's do the other one in green. Tangent. Now asymptotes are going to be, let me get some asymptotes in there. Asymptotes are going to be wherever cosine is equal to 0. So that's right here. And right here. So let me graph this thing in green. So close to the asymptote, it's going to go through this point. And there we go. So I got my red and my green. And so the question says, for how many values do they equal? They didn't ask what they were. They asked how many values. Well, there's a spot right there where they're equal. And there's a spot right there where they're equal. And those are the only 2 places. So the answer to this question is just simply 2. For what value of x does f of x, that is this one, equal 2? Well, let's see. There's the line y equals 2. So it equals it here and here. So at 0 and 2 pi. Okay, 0 and 2 pi. Now notice I put it in curly brackets. If you didn't, that's not good. So now it says for what value of x to the nearest hundredth is f of x greater than g of x. Now graphically that means f of x is above g of x. So let's see. When is f of x? When is the red function above the green function? Well, it looks like, let me do this in blue here. It looks like right here it's above. It also looks like from here over it's above. So I kind of got to find all right, we got a lot of things going on here. So it's above here, it's above there, it's also above here. So it's above between these 2 points. It's above over here. I just realized I had a mistake on my answer key. And it's above over here. So we're going to have 3 places where it's above. So I got to find those. And it said round to the nearest hundreds, which clearly means we're not going to be able to see this here. So let's go to graph mode. Change these over to -2 times 3.14 tab 4 tab 6.28. I'll just do it 6.28 and -4. All right, so let's graph these. Tab. Oh, escape. Tab. And we're going to graph 2 cosine x. So 2 times cosine x. There it is. And we're going to hit tab, and we're going to graph tangent of x. And we'll press enter. So there it is. So it's at these 2 points they're equal. Now we have to be careful. Right here, up until this point right here, which is pi over 2, the red is above. But as soon as the red gets past pi over 2, the red comes down here. So in this little piece right here, blue is above red. In this little piece right here, blue is above red. Now wait a second. We really only need to go from 0, right? So blue is above red here. And then at pi over 2, it stops. Blue is above red here. And at 3 pi over 2, blue is above. So we got 3 places. Well, what we got to do is find these points of intersection. That's the most important thing. So menu, analyze the graph, intersection, click, click. There's one place. And then menu, analyze the graph, intersection, click, click, and there's the second point. So I know I said around to the nearest hundreds, but whatever. So let's see. So from 0, and including 0, so we're going to include 0. So from 0 to, right here, 0.90, not including that point because it doesn't have an equal to, union, now we got to be careful. It's just this little part right here. So from pi over 2, not including pi over 2, to 2 pi over to 2.25 union, and then from 3 pi over 2 to 2 pi. And we'll include the 2 pi. So those are the 3 places where it's greater than. That was kind of tricky, I'm not going to lie. All right, so now we're looking to see when are they 2 away from each other. When is, another way to say this is, when is f of x 2 above g of x? For what value? Well, that's pretty easy. At right here, it's 2 above. At right here, it's 2 above. And at right here, it's 2 above. Now, the other ones are slightly less than 2 or slightly more than 2. So the answer there would be 0, pi, and 2 pi. Those 3 places. Again, mistake. And then what is, find the value of g of pi minus f of pi. Well, g of pi is 0 minus, what's f of pi? F of pi is negative 2. So 0 minus negative 2 is 2. All right, that's problem 1. How long did it take us? Woo, 10 minutes. That's why there's only 4 questions, because it's going to take a while. All right, that one's done. And that was the easier of the 3, I think. So this one's not bad, but I did change things up a little bit on you. I'm now graphing from negative pi to pi. So I want my y-axis this time to be right in the middle, or try to be right in the middle. And since these are not shifting up or down at all, I'm just going to put my x-axis somewhere right in the middle. Now the good news is, the only difference is I've got an amplitude of 3 here, and this is just a regular old cosine function, or regular old tan function. This is a regular old cosine function, but with an amplitude of 3. So this isn't difficult to graph. But I need to get my points in there, so let me get my points in there. Let's go 4 to the right, 4 to the right, and then 4 to the left, and 4 to the left. So this would be pi. This would be pi over 2. This would be 0. This is negative pi over 2, and this is negative pi. All right, so this is going to be a little bit tricky. 1, 2, 3, negative 1, negative 2, negative 3. All right. So here's where you're going to earn your money on this one. Because this is a normal pi function, we're going to get one full curve in 2 pi. But I'm not graphing to 2 pi. I'm only graphing to pi. So it's going to start at a minimum. Let me get a different color. It's going to start at a minimum. And it's going to end at a minimum, which generally would be over here, right? If this is pi right here, this would be where it would come down. So remember, cosine start at max, end at max, or start at min, end at min. In between, or at 0 and pi, we're at a max. So, and in between that, we're at 0. So this is going to look something like this. Now, again, we'll do the same thing off to the left. Start at a min, end at a min. In between, I'm going to have a max. So this is that function. Tough to look at, tough to graph, because I didn't have these points out here at 2 pi and out here at negative 2 pi. But we managed. We just thought about them. We'll get rid of them. We don't need them. They're not part of our graph. They're just going to help. They were just helpful. Now, if I remember correctly, and I do, there are asymptotes for the regular tan function at whenever cosine equals 0. So that's at pi over 2 and at negative pi over 2. And we'll graph that tan function. We'll graph it in, what am I left with, purple? All right, purple. And then starting here, I'm going to go in this direction. And starting here, we're going to go in this direction. So hopefully you see this. Don't do this on a normal graph, but I'm trying to get it so you can see it all. I didn't pick a very thick pen here. All right, so tan is the purple one, obviously. All right, so how many times do they hit each other? That's what this is asking. How many times they hit each other? Let's see, they hit each other once and twice. So again, this is 2. For what values of x does f of x equal 3? Now, f of x is the cosine. We want to know when it equals 3. It equals 3 here, and it also equals 3 here. So at negative pi, Remember, notice I'm using set notation, not interval notation. Negative pi and pi. That's just saying those 2 points, those 2 distinct points, not in between those 2 points, those 2 distinct points. All right, remember what this means graphically. F of x less than g of x. Graphically, this means when is f of x below g of x? Below. Graphically, that's what that means by being less than. So in other words, when is the cosine function, or green, below purple? So let me highlight that. Green is below purple here, but here it's above. So only in this little part it's above, or it's below. But at this point down here, notice green's above. And then green is below here, all the way up to, but not including this point, and then it becomes above. So it's 2 locations. Now I got to find these 2 points of intersection. That means I have to go back to my graph. And now I want to graph tab, 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 tab. Negative 3.14. Tab, tab, 3.14, tab. All right, so that's my graph. Oh, wait, hold on. I got to change these graphs. What am I doing? We still got the tangent function, but, oh, escape, tab. I got to change my cosine function to be negative 3. Now I'm going to find out if I'm right about this. So I'll go negative 3. Enter. Okay, there it is, right? Isn't this what we graphed? Kind of looks like what I graphed, but much nicer looking. Right? So where is, I don't know where the graph, the label for this one went, but where is blue below red? Well, remember, at this point right here, this asymptote at negative pi over 2, it's above. So from that point to here, and from here all the way over to this asymptote, it's above or below. So we need to find those intersection points. So menu, analyze graph, intersection, click, click, there it is. And then menu, analyze, not trace, analyze graph, intersection, click, click. And there we go. We got our 2 x values. So it is below from negative 2.13, negative 2.1, comma, pi over 2, to negative pi over 2. Oh, round to the nearest hundredths. I probably could round that pi over 2. Union, nearest tenth. If I had to round pi over 2, I could do that. Union, we're going to start at negative 1.10, negative 1.0, comma, and then all the way over to 3 pi over 2. Excuse me. All the way, we don't get to 3 pi over 2. All the way over to pi over 2. At pi over 2, there's another asymptote. So pi over 2. Now, if this truly did ask us to round to the nearest tens place, we really should go over here and say, okay, what is negative pi? Is that going to let me go? Pi divided by 2. And it's negative 1.6. So really, I should be using negative 1.6 here and 1.6 here, if in fact it asks for the nearest tenth. All right, where are they 3 away from each other? Let's see, they're 3 away from each other here at negative pi. They're 3 away from each other here at 0. And they're also 3 away from each other here at pi. All right, that's that one. That only took 9 minutes. And then there's this one. We must hate you, kids. So before I start tackling this problem, I want to start thinking about all the things that are going on with this one. I probably should get a much better idea of what's going on here. So I'm going to work with f of x here. So f of x has an amplitude that's 3. it has a b value of pi over 6. So that makes my period 2 pi over 6, which makes that 12. I'm not going to go through that math. You just divide, you multiply by the reciprocal, which makes my x scale 12 over 4, which is equal to 3. Okay. Now, all right, and then I have a c value of -2. Now, I don't want to start graphing yet because the scale factor is going to really screw us up. It's really going to screw us up. Now I want to do this one. My a value is 4. My b value is pi over 4. My period is going to be equal to 2 pi over 4, which is really just 8. Yep, 8. And then what? And I don't have a midline. Oh, I need my x scale. My x scale should be pi over, excuse me. What do we got? 8 over 4, which is equal to 2. So I think if I count by 2s, I can get all these 3s. Can I get those? Maybe I'll count by 1s. I'll just count by 1s. So let me get my axes in there. It only wants us to go from 0 to 1. We're going to earn our money on this one, kids. We're shifting down, so I'm just going to offset it just a little bit, make it a little bit higher since we're shifting down on that 1. All right, let's do the sine curve first. Well, I got to put my scale in. Scale is, let's make everyone 1. All right, good enough. Okay, we're going to earn our money on the sine curve. So let's see what we got. Well, let's just make remember we're going to make every box 1. So 2, 4, there's 6, 8, 10, and 12. So we're going to get out here to 12. So, sine curve. Oh, we need a midline. Oh, on it. We need a midline for the sine curve. That's why I wanted to do it first. There's our midline. You know what I'm going to do? Because I can. I'm actually going to draw it in, and then I'm going to delete it afterwards just to get rid of it. So, sine curve. It's going to start at its maximum. So the maximum here is -2 plus 3, which is 1. So it's going to... Oh, no, wait. This is the sine curve. No. Sine curve starts at 0. Ends at 0. It's got a period of 12, so we're going to start at 0, end at 0. And in between, we're going to have a 0. And in between that, which is here at 3, we're going to have a maximum. Maximum at 1, and a minimum at -5. So this will be our sine curve. Woo! That was fun. All right, let's do the other one in green. So this one is going to, it has no midline, so we're going to start here at the origin. But since it's a cosine function, it starts at a max and ends at a max, or starts at a min and ends at a min. In this case, we're going to start at a min because it's -4, so we'll start at -4. Now we're going to end at -4. But I'm going to end at 8. That's where this is going to get a little funky. I'm going to end at 8, which is right here. And in between, at 4, I'm going to be at a maximum of positive 4. And in between those, I'm going to be at 0. So at 2 and 6, I'll be at zeros. So this is what this one's going to look like. Now I got to keep going to 12. So at 2 more, I get back to a 0. And at 2 more of there, I get back to a maximum. Oh, man, that's a freaky one. There it is. Now, let's just see if we got this right. Still going to look at our calculator. We'll go back to this. But we got to go from 0. 4 is fine. 12. 4 is fine. Okay, escape. And tab, escape, tab, and tab. So we're going to do our first function is 3 sine, 3 sine. So 3 times the sine of control division pi over 6 x minus 2. Enter. We don't have enough. Oh yeah, we had to go down to what do we have to go down to on our graph? We had to go down to -5, so we're certainly going to need some more down here. Let's go make this -7. All right, there we go. All right, so that's that. And then let's hit the tab button. And we'll do other one, -4 cosine parentheses. What do we got? Pi over 4, control division pi over 4 x. Oh, that's it. Enter. All right. So is that what we got? Is that what our graph looks like? Something like that. Kind of looks like that, right? Yeah. Green above. There it is. The red. Maybe you can change the colors. Can't change the colors, can you? All right. Can't change the colors. All right. So that's that. It is. All right. So now let's answer the questions. Well, let me pause and then we'll come back and answer. So to answer the question for how many values does x equal f of x, or f of x, for x, does f of x equal g of x? In other words, how many times do they intersect? I only have one. On my graph, I only have one. But I want to go look at the calculator and see, okay, just that one place. Now, it was close down here, but it's really just that one place. All right. We're in pretty good shape then, just once. So that answer is just once. For what value of x does f of x equal -2? Now, f of x was the sine function we did in purple. So it equals -2 here, here, and here. So that's 3 values. So at 0, 6, and 12. For what values is f of x, that's the sine function, or green, above purple? Or on our graph over here, when is, in this case, it's red above blue. So it's going to be, here green is above purple. F of x, wait a second. F of x is purple. So when is purple greater than, and g of x is the cosine function, which is green. When is purple above green? So when is purple above green? Well, it's above here. And that's it. From there to there is the only time purple is above green. So I just got to find that point of intersection. So menu, analyze graph, intersection, click, click, 2.25. So the answer to this is quite simply from 0 to 2.25, not including the 2.25. All right, for what values of g of x minus f of x equal to 2? Well, let's see. They're 2 away from each other here. They're 2 away from each other here. I guess that's it. 0 and 6. I also have 9 for some. Oh, yeah, right here. Look. They're 2 away from each other at 9, too. So also, common 9. Let's squeak that in. All right. And when are they 6? Oh, wait. What is f of g of 6 minus f of 6? Well, g of 6, the green of 6. Which one's g? G was green. Well, that was good. I made it green. So when is g of 6 is 0 minus f of 6, which is negative 2. So that's equal to 2. Woo! All right, we got one last one. Let me save this and I'll be right back. And now we end in a word problem. Everybody's favorite word problems. Wegmans temperature T varies with the time of day H. During the course of one day, as represented by the function, T of H is equal to 7 cosine pi over 3 H plus 75. The air conditioning operates when T is above 80 degrees Fahrenheit. Graph this function for a 24-hour day and determine to the nearest tenth of an hour the amount of time in one day that the air conditioning is on in Wegmans. Oh my God, Mr. Krause, there's like 400,000 words in that sentence, and it's bothering me. All right, so since we're working in real life, let's put our axes down here. Wait, do we go below 0? I don't think we're going to go below 0, so let's put our axes down here at the bottom. Inside the Wegmans grocery store, there will be no 0-degree temperature days. As a matter of fact, I doubt it gets below like 50 in there. So why don't we just put a little break in here, and we'll call this, I don't know, I got to get up to at least, let's see, my midline is C, which is 75. So my max, let me draw in a little, my max is going to be C, 75, plus 7, which is 82. So I need to get up to at least 82. And my minimum is going to be 75 minus the amplitude, which is 7, which is 68. So I really only have to get between 68 and 82. That's all I need. So let's say I got here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, so it's 19. So if I start at 50, that would only get me to 69. So I can't start at 50. I only got to get to 68. So let's start at 66. 67, 68, 69, 70, 71, 72, 73, 74. 66, 67, 68, 69, 70, 71, 72, 73, 74. Oh, gosh. 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84. So it looks like I got it. So Guys, you got to make sure. Now, I don't want to see 0 to 80 and see the graph up here at the top like this. That's meaningless. Totally meaningless. Useless. I don't want to see that. All right, so let's graph this sucker. So we're still working with this thing. We got our A of 7. We got our B of pi over 3, which makes our period equal to 2 pi over 3, which is really just 6. Our x scale is going to be 6 divided by 4, which is really 1.5, so that's kind of a pain in the neck. We'll talk about that. We'll work on that. My midline is 75. I already talked about that. Is that all I need? All right, let's graph the midline in first. So my midline, I think I can do this in green. It'll sort of see it. Let me just draw it like this, and then I'll get rid of it later because I don't really need it. But I need it to help graph this function. Okay. So because this is positive, it's going to start at a maximum. So we'll do this in red. Start at maximum, which is 82. Oh, now I got to get to 24. Son of a gun. That means I got to make every one of these 2. 2, 4. Because I can't get the 24 if I don't. So 1, 2, 3, 4, 5, 6. That's 12. 1, 2, 3, 4, 5, 6. That's going to be 24 hours. So I got to do it for 24 hours. You know what? I think what I can get away with is making every one of them 3. No, I can't do that. What am I thinking of? There's 20 boxes, approximately. That's all right. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is 12. Okay, so it's going to start at a max, and because so that means at 3, 1, 2, 3, there's 6, and here's 18. All right, you'll see why I need those in a minute. It's going to start at a max. It's going to end at a max. Well, what is my period? My period is 6. It's probably 6 hours. So that means between 0 and 6, it's going to start at a max, end at a max. And then halfway in between those two, it's going to be at a min. Now, the min is 68. So halfway between those two is right there. So I got to get 4 of these in. 1, 2, okay. So this is going to be ugly because it's so tall. And then another max at here, another max at here, and another max at here. That means halfway in between here is going to be a minimum. Means halfway in between here is going to be a minimum, and halfway in between here is going to be a minimum. So I got to get these graphs in. Now I know the frequency is 4. I don't know what I was just saying. Let me just keep going. Again, should show you my answer key. It makes it look so much nicer. Okay, there's that. So the question says, graph this function for a 24-hour day. should have made a nice, an easier function. So let's see what we got. The other thing I got to graph is it's going to graph, the temperature is only going to come on if I get above 80 degrees. So I have to graph 80 degrees. So let me graph that in green. Y equals 80 degrees. So over this, so it looks like from here to here it's above. 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 And from there it's above. So I got to figure out what all those times are. It's 1, 2, 3, 4, 5 times. All right, good. So now I'm going to go with my calculator. And I got to graph this thing. And let's just make that 24, tab. 60, tab, oops, okay, tab, negative 60, no, oh, I can't have 60, oh, shoot, let's just go with 0 for now, tab, 0, tab, what did I have to get up to, 82, so we'll go 90, tab, 60. Enter. All right. Let's hit the tab button. Go up. Change. Get rid of this. Up. So we're going to go 7 times. What are we doing? Cosine? Cosine of control division pi over 3 x plus 75. So there it is. 1 full curve, 2 full curves, 3 full curves, 4 full curves. It looks a lot nicer on there, doesn't it? All right, it looks a lot nicer on there. Now we're going to graph the line y equals 80. So all of these points of intersection are important because this is where it's above 80, this is where it's above 80, this is where it's above 80, and over here and over here. So I need all those points of intersection. So menu, I think I can do geometry, points and lines, points of intersections. Graph. Oh, okay. So I found them all. Oops, Control Z. Oh, please, yes. All right. So this one's for this last one over here, and this one's over here for this one. So, whoo, that's a lot. So, from 0 to 0.74. Oh, we're going to round to the nearest tenth. So, the intervals are, let me stop, I'll be right back. All right, so what I've done is I've taken the liberty of going to the calculator and going, okay, from 0.7 to 5.3. 6.7 to, from 5.3, should probably 5.3 to 6.7. From 11.3 to 12.7, 17.3 to 18.7, and so on and so forth. So I'm going to add these up, 0.7 plus, this is 1.4, plus, this is 1.4, plus 1.4, plus 0.7. And when I add all those up, I get 5.6 hours. All right. I guess that's it. That's all she wrote for that one, kids. That was a fun question. Hit the subscribe button. Hit the thumbs up. Even though this is tough, still hit the thumbs up, telling me that you like what I'm doing for you. And that Miss Newman and I are getting you some good stuff out there. Okay, kids? Catch you on the flip side. Bye.